We're going to look at here how to add rational expressions, and I'm going to start with some that have the same denominator. And this is going to be the easy case. Most of the time, though, we're not going to have this, but what happens when you add 1/4 plus 2/4? It may be instinctual to you that this is just going to be 3/4. You just have to have the same denominator, and you just add the numerators. And the reason that works, if you have 1/4 right here, I'll color that in, and then I have, say, 2/4 added to it. I'm able to add those together because they're the same piece or the same size of the puzzle, so to speak. So I have 1/4, add 2/4 to make 3/4. If my sizes were different, as I'm going to show you in a minute, you're not able to add those. So if you have the same denominator, you just add the numerators, and it's as simple as that with a regular fraction. So with rational expressions, if we have the same denominator, the same applies. I can just add my numerators. 3 plus 5 is 8, and you just keep the denominator the same. So that's 8 over 2x minus 1. Same holds true when you subtract, but when you subtract, remember, that negative is going to distribute through that. So we have the same denominator, 3x. We have x minus 6, minus 4x, and then minus 2. Okay, that negative does go through there and distributes. Now I just want to clean the top of it up and get negative 3x minus 8 over 3x. And you would want to look and see, does this reduce at all? But I can't cross the 3x's, remember, because this 3x is attached to 8. So this is as good as I can do with this. So if you have the same denominator, it's rather easy. Just combine the tops and leave the bottoms the same. Let's say we have different denominators here, 1/3 plus 1/6. Why can we not just add here and not worry about the denominators? And the problem is 1/3 is this much of the rectangle, and 1/6 is this much. So I can't add this piece and this piece because they're different sizes. I need to break each rectangle up into the same amount of pieces and then add. So the same amount of pieces would be something called my LCM or LCD. They're synonymous terms, really. LCM stands for least common multiple. LCD would be least common denominator, and it applies to fractions. But we're going to look at how to find the LCM of two pretty simple numbers, actually two problems here, and then we're going to extend that to rational expressions. So in this case, what we want to do is factor the number. And to factor the number, we go back to a prime factor tree, which in this case I chose numbers that are pretty small and easy to do in your head. What is a prime factorization of 3? Well, that would just be 3 because 3 is prime. What is a prime factorization of 6? Prime factorization of 6 would be 2 times 3. And to find the LCM, what you need to do is list every prime factor that you see along both of these. So what all do you see down here? I see a 3. If you cross the 3 out, I cross it out here as well. I don't need to list it twice here. And I see a 2. So I've used every number that I see amongst the prime factorization of each. So my LCM would be 6. So if I was to go back and do this problem, to be able to add them, I would need a denominator of 6. Okay? This one already had a denominator of 6. To get to 6, I would have to have multiplied by 2. To compensate for changing the bottom, I need to multiply the top by the same number that we multiplied to get the bottom to where it needed to be. 1 times 2 is 2. And now what I've done is taken both rectangles and divided them into an equal amount of pieces. The size is the same, so now I can add them. I've got 2 pieces plus 1 piece, they're the same size, so that adds to 3 pieces, and of course that reduces, in this case, to 1/2. Now what about 4 and 10? Let's do the same process. Now this 4 and 10 has nothing to do with this illustration, but 4, prime factorization is 2 times 2. 10, prime factorization is 2 times 5. So what's the LCM? Now up here, when I took the 3 out, I took it away from both. So if I take this 2 out, I've taken this 2 out, I can go ahead and cross that 2 out. But in this case, I had 2 2's in the same number. So for the LCM, now this is the first 2. For the LCM, I do need to list it twice because it showed up twice in the same number. So the LCM would be 2 times 2, and then I've got the 5. 2 times 2 times 5, that multiplies to give you 20. So to find the LCM, you have to do the prime factorization, and the LCM must consist of every prime factor you see, but if a prime factor shows up more than once in the same number, then it's going to have to be listed more than once in the LCM. Now for rational expressions, we have denominators that are polynomials, x plus 2 and x squared plus 9x plus 14. And again, we can't just add across here because we have different denominators. What I have to do is calculate an LCM. And again, factoring is very helpful here. Can't factor x plus 2, but x squared plus 9x plus 14, of course that's x plus 7 and x plus 2. So from this, let's figure out our LCM. Remember, my LCM has to have every factor I see along the bottom. Well, what's along the bottom? I have an x plus 2. And remember the concept of glue here, this plus attaches those two. So x plus 2 is one factor. And it shows up over here, but I don't have to write it twice. And then I need my x plus 7. My LCM, the same concept as before, is must consist of everything you see along the bottoms. The only difference here is the fact that we factored with a procedure instead of doing a prime factor tree. So both fractions need this denominator. This fraction already has it. This fraction needs an x plus 7. I'm going to put x plus 7 on the bottom. Squeeze it in here, x plus 7. I should have probably given myself more room, but since I put x plus 7 on the bottom, I've got to compensate by putting it on the top. Now once we establish our denominator, LCM, it's going to stay that way for the remainder of the problem. I'm not going to do anything to the bottom anymore. But what I do want to do is clean the top up. Now notice that I did write them backwards here, and that doesn't matter. As long as I've got the same factors, I'm fine. So I can put the two tops together now that I have the same bottom. So I'm going to distribute my 5. It's 5x plus 35 plus 6x. 5x plus 6x is 11x plus 35 over my denominator. Again, my denominator, I typically just leave it and not multiply it out or anything. And for this problem, we will mention that my excluded values are -2 and -7. Remember, my denominator can never equal 0 here. I'll do one quick subtraction problem. Again, we're going to factor here. X minus 3. The factors of 9 to add to 6 are x minus 3 and x minus 3. And the factors of -77 to add to 4 are going to be x plus 11 and x minus 7. Okay. Now if you'll notice on this one, we can make life easier by simplifying. I can make this 1 over x minus 3, because you can't vacate a top. You have to leave the 1 there. And then I'm going to give myself some room here. Plus 11, x minus 7. Okay, so sometimes you can cancel as you go. Let's do the LCD over here, least common denominator, or LCM, least common multiple of the denominator, whatever you want to call it. So what are all the factors down here? We'll have x minus 3, x plus 11, and x minus 7. Okay? So this fraction needs these two, x plus 11 and x minus 7. So we'll give that to the top and to the bottom. This fraction only needs the x minus 3. I've got to give it to the top and to the bottom. And we now have the same denominator, even though the factors are presented in a different order. So these denominators do match, even though they're in a different order. Now we got to clean the tops up. So we're going to FOIL these. X squared minus 7x plus 11x minus 77. And remember here, this minus is going to distribute through. So it's as if you're distributing a negative x. This is minus x squared and plus 3x. Minus x times minus 3 is positive 3x. And as long as we get the same factors, we can present these in any order here. Now we've got to clean up the top. So our x squareds are going to cancel. Negative 7x, 11x, and 3x. That's going to make 7x. And I've got the negative 77. So interestingly enough, you can factor a 7 out of there. But our denominator, I'll squeeze in here x minus 3, x plus 11, and x minus 7. And our excluded values, which I don't have room here, but you could mention those, would be positive 3, negative 11, and positive 7.